Hello! I'm working on several videos right now, like part 3 of my brushless DC fan series and a new very detailed video in which I will explain how uninterruptible power supplies work internally. But even after 4 days of reverse engineering, that video is far from ready. Therefore, I decided to upload a little video about a fun project that I have spent some time on during the last week as well. It's a quadcopter project. As you certainly know, a quadcopter is a multi-rotor helicopter with 4 rotors. Quadcopters need electronic control circuitry and sensors to be operated in a stable manner, and that's something I want to take a look at earlier or later. This first video about the project, however, will deal with another issue of quadcopters. They normally use very expensive brushless DC motors, and their body is often made of equally expensive carbon fiber parts. Since I've been dealing so much with BLDCs in home appliances lately, I want to find out if it's possible to use super cheap salvaged BLDCs from axial fans to lift something off the ground. Another question is if it's really necessary to use high-tech materials like carbon fiber, or if there are very cheap everyday materials that can be used to build a quadcopter as well. The first thing for me to do was to look for very small but powerful brushless DC motors. This is a 750 watt server PSU. I bought several of these on eBay to salvage parts for power electronics projects from them. They only cost me a few bucks and every unit carries 2 BLDC fans. After removing the fans from the enclosure, I cut the motors out of their frame. And remove the wings entirely. I, however, have to leave the plastic base intact to mount the motor on the structure that I am about to build. Next, I bought a set of spare propellers for a commercial quadcopter on the internet. They cost me around $3. After cutting off the plastic shaft and working on the rotor's metal surface with some sandpaper, I glued one of the propellers on top of one of the motors. The glue which I use in this video is a special mounting adhesive. I use it a lot lately and I really recommend you to buy this stuff. It's super strong and has good plasticity. After doing the same thing with another motor and waiting for the glue to harden, I drilled holes in the plastic bases of those motors. Why did I do that? Well, I did that to attach the motors to the second best thing to fancy carbon fiber. Ordinary wood skewers. Then I slid one of the motors over a pair of those skewers and attached a second motor on the other end, as you can see here. I again used mounting adhesive to hold the motor in place. For the other 2 motors, I had to do it in a slightly different way, as you can see here. I had to mount the other 2 motors upside down. The propellers were also glued on top of the motors in an upside down manner. Why did I do that? Well, you can operate a quadcopter basically in 2 different configurations. One configuration that you can call the plus configuration and another one that looks like an X or H. While these arrows show the direction in which the quadcopter is supposed to fly in a forward manner. All flying operation is basically controlled by changing the relative speeds of the 4 motors. But no matter which configuration is used, you always need 2 propellers to rotate in clockwise and 2 to rotate in counterclockwise direction. If you don't do that, the copter will not be controllable. But a problem with the motors which I have salvaged from the PSUs is that they can only move in counterclockwise direction. Therefore, I have to turn 2 of the motors upside down. It would be possible to change the circuitry inside the motors, but in order to do that, I would have to destroy the plastic base on which the motors are mounted. Now I had to connect the 2 parts together. What I did first was to put them both into place and hold them together by copper wire, which I also soldered together to get better grip. Then I added a small brass tube mounted on an aluminum sheet. I again used mounting adhesive in an excessive manner. What is that piece of pipe good for? Well, wait and see. But before I could test this thing, I first had to solder two long, thin and flexible pieces of wire to this contraption. I also did some ghetto-style heat shrinking with a very girly lighter. After waiting for the glue to harden, the big moment had come. The big question would be if I could make this thing lift off and hover over the ground. But because I haven't added any control circuitry yet, I devised a simple mechanical guiding mechanism that will prohibit the assembly from destroying itself and everything in its way. It's a simple steel bar mounted on a piece of wood. Now it's finally time for a first test. I will now connect a 12-volt battery. As you can see, the experimental quadcopter lifts slightly off the ground, but can't keep itself in the air. What we need is more power. Therefore, I now connected two 12-volt batteries in series and attached an adjustable buck boost converter that will enable us to supply the motors with anything from 1.2 to up to 60 volts. I will now start at around 10 volts and crank the voltage up slightly and see what happens. And tada! As you can see, we have a liftoff. These motors can usually be operated at voltages of around 15 volts or higher, but they might not hold up very long. So I guess in theory motors like these could do the job, but further testing is required in any case. I hope that I will make further advances in this project, and I guess there will be a follow-up at some time in the future. But other than that, we'll meet again in a few days when my next videos will go online. So if you like this video, watch my other stuff and please subscribe to my channel.